Hi बच्चों, this is lecture 5 of number theory. Here we are going to discuss HCF and LCM in detail with all of their properties and some of the Olympiad questions that will be taken from HCF and LCM only. So let's begin. We have already studied a bit about HCF and LCM. So just a quick revision. What is HCF? HCF of two or more integers, we say two or more integers, is the largest possible or we can say largest positive integer that divides each of these integers without remainder. It means that divides each of these integers with remainder equal to 0, with r is equal to 0, also known as GCD, that is GCD, greatest common divisor. For example, if integers example a and b are two such integers, then we say HCF AB or GCD of AB. It is stated like this. So example, if I say HCF of 12, 18. Now for 12, so we list the factors and then we find out. So if I say the factors, how do we choose? 12 has factors 1, 2, 3, 6 and 12. What about 18? 1, 2, 3, 6, 9, 18. So which is the highest one? 6. So HCF of 12, 18 will be 6. Basically, some can do like this. Okay, sir, 12 is written as 4 into 3, that is 2 square into 3, and 18 is written as 9 into 2, that is 2 into 3 ka square. So take lowest factors. So HCF will be lowest factor 2, lowest factor 3, answer is 6. We did it in the previous lecture. Okay. So actually this will be known as prime factorization method. This is prime factorization method. Okay, prime factorization method. And again, so there is another way. This will be known as prime factorization method. I can give you another example. For example, if I ask you HCF of 48, 72. So you will say, sir, 48 is equal to 8 into 6, that is 16, 2 to the power 4 into 3 to the power 1. 72 is 36, that is 4 into 18, that is 2 ka cube into 3 ka square. So sir, HCF lowest power 2 cube and 3. So HCF will be 2 ka cube into 3 ka power 1. So this will be 24. So HCF is 24. But actually there is another way to find HCF. Second way to find HCF, and that is by Euclid's division algorithm. Those who have already studied class 10 or are in class 10, they have already studied this way. That is Euclid's division algorithm. We say Euclid's division algorithm. So what does it state? We know if AB belongs to Z plus, there exists QR such that where QR belongs to set of integers such that A is equal to BQ plus R, where R ranges from 0 to B. Done. So this is the way in which we find HCF. So what are the steps? Simple step. First, apply Euclid's division lemma. To apply Euclid's division lemma to two numbers, say A and B, where A is greater than B. Second, R is equal to 0. If R becomes 0, HCF will be what? Which will be the smaller number? So HCF is equal to B. Third, if R not equal to 0, apply division lemma to what? B and R. whatever is the remainder, then go for B. Fourth, continue the process. Continue the process till R becomes 0, till R is equal to 0. For example, if I say find HCF of 272 and 1032, how we do this? See, 1032 and this is 272. We start dividing. So 272, if I choose 4, it will go bigger. So 3, 3 to 6, 7, 3, 21 and 3 to 6, that is 8. So what is the remainder? Remainder will be 6 and there is 1 and here is 2. So 216. So 216 again will be divided by 272. So it will be 1 and again it will be 56. So 56 divided by 216 will be what? 3, and this will be 50, 168. So again this will be 48 and then 56, again remainder will be what? 8. So basically last stage is 8 when divided by 48. So this will become 8, 6, 48 and the remainder turns out to be 0. So what happens? 8 divides actually both 272 and 1032 and that is the highest common factor for them. So HCF 272 1032 is equal to what? Is equal to 8. Done. Now next is LCM. So what is LCM? So we say LCM is also known as lowest common multiple. So of lowest common multiple of 2 or more integers. 2 or more integers is smallest positive integer which is multiple of all the given integers. Multiple of all the given integers. Okay, multiple of all the given integers. So how do we write LCM of a comma b, where ab is an element of z plus, is equal to written as LCM a comma b. For example, if I ask you LCM of 12 comma 18, how do we do this? So basically we choose the common multiples. So what are the multiples of 12? 12 multiples, we are talking of multiples of 12, that is, read the multiplication table: 12, 24, 36, 40, 48, 60 and goes on. For 18, 18, 36, 54 and goes on. But can you see 36 is common to both of them? So therefore LCM is 12 comma 18 is 36. Done. So what are the methods? First, methods to find LCM. Now these are all the things that you have already studied, so I am just giving it in 2x. First, it is prime factorization. So in prime factorization, what we usually do? So prime factorization, basically I can take an example. We take the highest powers of all the prime factors. For example, 48 and 72. So 48 again can be written as 2 to the power 4 into 3. 72 is 2 ka cube into 3 ka square. Now LCM 48, 72 will be chosen amongst the highest powers. So which is the highest power? 2 to the power 4 and this was 3 to the power 1 and 3 to the power 2. So 3 to the power 2 is the highest one. So 16 into 9, that is equal to 144. Done. Done. So this is the way we find the prime factorization method, and actually that is the only way we will use, and so instead of writing all the methods, we can use prime factorization method. This will be easy. Okay, now list some of the properties of HCF and LCM. So first property number A: for any two positive integers, for any two positive integers a and b, a and b, the product of their HCF and LCM is equal to the product is equal to the product of the two numbers. Product of the two numbers. Done. What does this mean? It means HCF of a comma b into LCM of a comma b is equal to a into b. Now, why? I think you have already studied this property. I can give an example. For example, there are two numbers. Let a is equal to 12, b is equal to 18. Let's prove this. So HCF 12 is 2 ka square into 3 per power 1. 18 is 2 into 3 ka square. That so HCF 12 comma 18 will be what? Smallest power choose 2 into 3, that is 6. LCM 12 comma 18 will be what? Choose maximum power 2 ka square into 3 ka square, that is equal to 36. Now HCF into LCM. So HCF into LCM, this will be equal to 216, and A into B will be equal to what? 18 into 12, that is equal to 180 and 36, that is 216. Done. अगर प्रूफ्स देखनी है बच्चों तो प्रूफ वी कैन डू लाइक दिस कि मान लेते हैं क्योंकि दो नंबर ले रहे हैं ए और बी, तो ए का प्राइम फैक्टराइजेशन ऐसा मानते हैं p1 पर पावर x1, p2 पर पावर x2 एंड दिस गोज ऑन pn पर पावर xn. अगेन b कैन बी रिटन एज p1 पर पावर y1, p2 पर पावर y2, सम pn per power yn. Okay, so I am taking just the same prime numbers. So p1, p2, maybe there can be something more, pn plus 1, but I am not taking it now. I am just trying to prove it simply. So our prime numbers, these are prime numbers, and there is another thing, xi comma yi is greater than equal to 0 are integers. It means all exponents. I am talking of exponents. They are integers. Now, by definition, what do we mean by HCF? By definition, so we can say HCF of a comma b is equal to p1 minimum of x1 comma y1, p2 minimum of x2 comma y2, again pn minimum of xn comma yn, and for LCM, what do we say? LCM a comma b can be written as p1 max of x1 comma y1, p2 max of x2 comma y2, and this goes on till last. So how do we do it? Next, now if I multiply, HCF a comma b into LCM a comma b, so we'll say p1 minimum of x1 comma y1, and this goes on dot dot pn minimum of xn comma yn, and again this goes on till p1 maximum of x1 comma y1, and this goes on till pn maximum of xn comma yn. Okay, now so this becomes equivalent to, let's say, p1 minimum of x1 comma y1 plus maximum of x1 comma y1, now, and this goes on for the rest of the thing. But tell me, if xy greater than equal to 0, xy belongs to z plus, and if somebody says minimum of x comma y plus maximum of x comma y, so what is the value of this? Minimum of x comma y, let x be smaller than y, so minimum of x comma y will be x, maximum then will be y, so x plus y. So this minimum of x comma y plus maximum of x comma y is equal to x plus y. So therefore here what is going to happen? So p1 per power, this is equal to p1 per power x1 plus y1 into p2 x2 plus y2, and this goes on. So basically if I make it different, like if I remove the exponents of each and take likewise exponents x1, x2, x3, and this goes on into p1 per power y1, p2 per power y2, and this goes on. So what is basically this? This is a and here it is b, and hence this is proved. Why? Because a was what? A was p1 per power x1, p2 to the power x2 and goes on, and b was p1 per power y1, and this goes on. Done. Now next property. So next property number 2. So this is property 2. Now what does property 2 says? Remember, HCF of a comma b comma c into LCM of a comma b comma c is never equal to a into b into c. This never happens. But what is the relationship? LCM of a comma b comma c is equal to a into b into c into HCF of a comma b comma c divided by HCF of a comma b into HCF of b comma c into HCF of c comma a. HCF of c comma a. Now this becomes quite difficult. We are not required to prove it. Unnecessarily we are not going to prove it. But we understand one thing with an example. For example, say let's take one of the example. For example, a is equal to 12, b is equal to 18, c is equal to 30. So what is a into b into c? Now a can be written as, first write it as a term of prime factors, 2 square into 3. Again this can be written as 3 square into 2. 30 can be written as 3 matlab 2 into 3 into 5. Done. So a into now let's see whether the formula is correct or not. So what is LCM of 12, 18 and 30? How do we find out? So we take maximum power of 2, 2 to the power 2. We make maximum power of 3, 3 to the power 2. And what else is left out? So left out is 5. So basically 4 into 9, 36, 180. So LCM is 180. Now what is the HCF of ABC? HCF of ABC, that is smallest common power. So 2 is common, and again 3 is common, and smallest also. So HCF is 6. Now again let's try to find out whether 180 comes from right hand side or not. So if we take RHS, a into b into c, that is 12 into 18 into 30, and HCF of ABC is 6. Again HCF of a comma b, 12 comma 18, this will be 6. 18 comma 30 again 6. 12 comma 30 again 6. So if I start cancelling, 6 to 12, 6 3 18, 6 5 30. What is the value? 30, 90, 180. Super. RHS is equal to LHS, and this is true, and this is true. So done. Now again if we are required to say that this is true, we can do one of the thing. We can say, like if we try to arrange, for example, say there is a, there is b, there is c. I am trying to just give a simple proof. If you need to understand this, why it is happening. So I can say, suppose for a, b, c all, there is a prime factor. There is a prime factor p. Prime factor p that exists. For all. For all. That exists for all. Matlab common to all. So let's say exponent of p, here it is p to the power x, here it is p to the power y, here it is p to the power z, and say the order is like this. x is less than equal to y is less than equal to z. Now for left hand side, what we are required to do? We are required to find LCM. LCM of what? LCM of a comma b comma c. So how do we find LCM? We find maximum of x comma y comma z, which is equal to z. Now see for right hand side. So what is right hand side? X, we need to find, let's find exponent of p for each term. Now, so in a into b into c, so how do we find the exponent? P to the power x, p to the power y, p to the power z. So this will be x plus y plus z. Done. Okay. Now for HCF of a comma b comma c, what is the exponent? I am only talking of exponent. I am not writing the base. So exponent. So this will be x. Superb. HCF of a comma b. This will be, so minimum of x comma y. So this will be x again. Okay. Superb. Now HCF of b comma c. So it will be y, and HCF of a comma c, it will be x again. So if we say how to find exponent on RHS, so on the numerator we'll add all the exponents, x plus y plus z. Again there will be another exponent plus x, and we are required to subtract whatever is there in the denominator side. So HCF of a comma b, b comma c, c comma a. So minus x minus x minus x minus y minus x. So what is left out? Plus x minus x gets cancelled, y gets cancelled. So answer is z. Super. So LHS and RHS, they have the same exponents. Now I am only talking of exponent. If you want to write like this, p to the power x plus y plus z into p to the power x, you can go for that. Again, ultimately we are required to solve the exponents only. So therefore LHS and RHS are equal. So this is done. Next property. So how many properties are done? So two of the properties are already done. Yeah, I guess two are only done. Okay, let's write this as not as a, right? Just this as 1. Okay, so property 2 is done. Now next property, let's say 3. So the HCF of a set of numbers is always a factor of their LCM, is always a factor of their LCM. Now again, what does this mean? It means, suppose there are any set of numbers, let's say, not solution, I'll write the proof. What does this state actually? Say, let the set of numbers be a1, a2, and this goes on till ak. What we are required to do? We are required to find the HCF of this set of numbers and to prove that it is always a factor of their LCM. Okay, so let H is equal to, say, HCF of a1 comma a2 till ak, and consider L is equal to LCM of a1 a2 till ak. Superb. It means if HCF of this a1 a2 ak is H, it means H divide, what does this imply? H divides AIs, and I ranging from 1 to k. Okay, so again, therefore we can write, say, AI is equal to H into some mi for mi belonging to Z. Okay, done. Now also, what about LCM? So by definition, what does LCM say? By definition, LCM means L is multiple of A1, A2, and till ak. Okay, that here it is multiple. It means eventually L is also, say, multiple of L is multiple of what? Any i's. So let's say a1. So we can write L is equal to sum a1 n1. Say for some integer n1, for some integer n1. Now think like this. If I substitute, this is equation first, let's say this is 2. Now start substituting. A1 is equal to h into m1 somewhere, and L is equal to a1, which is h m1 into n1. Okay, so basically this can be written as h m1 n1. Now m1 n1 belongs to set of integers. It means product is also an integer. Product is also an integer. Now if product is an integer, it means what we can say, L is multiple of h. Of course it is true. L is multiple of h. That was required to be proved now. It means the HCF of a set of numbers is always a factor of their LCM. True, whatever be the set of the number, if you find the HCF, it is always a factor of the LCM, and we have proved it. Next, property 4 बच्चों, property 4. So it says for fractions, how do we find the HCF and LCM? So HCF of fractions, say it is written as HCF of numerator divided by LCM of denominator. And what about LCM of fraction? So it is LCM of numerator divided by HCF of denominator. HCF of denominator, done. Now for example, if I say find HCF and LCM of 2 by 3 and 4 by 5. So how do we do this? Say solution. Now what is the way out? 2 by 3 and 4 by 5 is there. So if I find HCF of 2 by 3 and 4 by 5, so we have to take the HCF of the numerator, which is 2, and 3 and 5 LCM. So this is 15. So basically HCF will be 2 by 15. And what about the LCM? LCM of 2 by 3 comma 4 by 5 will be LCM of the numerator. So this will be 4 divided by 1. So answer is 4. Done. Next property, property number 5th, property 5. So what does 5th property says? Okay, first let me add some of the pages. I think that will be sufficient, bachcho. Done. Yeah. So where were we? Yeah. Now so find HCF and LCM. That's done. Next property 5th. It says if HCF A comma B is equal to H and A is equal to H of X and B is equal to H of Y for some integers X and Y. Now which will be true, X and Y? Then such that HCF of X comma Y is equal to 1. Then the numbers X and Y are called coprime. Now this is true. That is the meaning of coprime. Two numbers are said to be coprime if one is the only common factor between them, and that is true. So do we require to prove it? We don't need to require to prove it. But if you say that generalize it. So I can generalize with the help that A is equal to h of x is written and B is equal to h of y is written, where x comma y belongs to the set of integers. What we are required to prove, HCF of x comma y is equal to 1. Now we are required to prove this, that HCF of x comma y is 1. So how do we do this? Now actually see, this is easy to prove, but remember one thing. Here we are saying that if A is equal to hx and B is equal to hy, then HCF of x comma y is 1. So how do we do this? Actually this is an extra statement कि numbers x and y are called co-prime. Of course co-prime means the HCF is 1. But how do we prove that HCF of x comma y will be 1 always? That is to prove. So instead we can do one thing, prove by contradiction. We can use proof by contradiction. So what do we mean by contradiction here? So we will assume, let's say it is not 1. Let's say HCF of x comma y, let's say it is equal to d, where d is greater than 1. Okay, then x is equal to what? Say some d into z, and y is equal to what? Some d into w. Again here z and w are integers that belongs to the set of integers. Now what is a is equal to hx, so we can say, let's say this as equation first. So if a is equal to h of x and x is equal to dz, which implies a is equal to h dz. Again for b it will be equal to h of y, which is again equal to h dw. So here in this case a is equal to h d into z and b is equal to h d into w. Okay, now it means h into d is common factor for both a and b, as we can see, common factor of a and b, but we assumed something else. Now since d is greater than 1, why? D is the HCF. So we didn't assume that HCF is 1. So HCF is D. So D is greater than 1. Now if D is greater than 1, then HD is greater than H. Okay. Now the problem is that what we assumed that H is the highest common factor of A and B, but HD is coming greater than H now. So our initial assumption fails. Our initial assumption fails that H is HCF of A and B. Why? Because there is another highest common factor, that is HD is coming. So therefore D greater than 1 is false, and hence D is equal to 1, which means HCF of x comma y is equal to 1. This is what we are required to do. Okay, done. If you did not understand, let's say one of the example. Now HCF, we know 12 comma 18 is always 6. So here what is A? A is 12. What is B? B is 18. Then 12 can be written as 6 into 2 and 18 can be written as 6 into 3. Yes or no? Now x is equal to what? 2 here. Y is equal to what? 3 here. So HCF of 2 comma 3 will always be what? HCF of 2 comma 3 is 1. So 2 and 3 are co-prime. Done. That is the statement. Next. So the properties are over. We'll move on to the questions. Or maybe if some of the properties are there more, we'll add it later. we'll see the questions first and then we will add some of the more properties that are of vital importance in Olympiad. So let's see the question first. The LCM of two numbers is 14 times their HCF. 14 times their HCF. The sum of HCF and LCM is 600. If one of the numbers is 280, find the other number. Now this question basically will imply that HCF into LCM will be equal to A into B. That we can do, or we know there are 2 or 3 equations that are given. What? Let two numbers be A and B. Okay. Now what is given? HCF of AB, let's say this as H, and LCM of A comma B, let's say this as L. Now according to question, LCM of two numbers is 14 times their HCF. So L is equal to 14H. Equation first. Sum of HCF and LCM, L plus H is 600. Second. Now if one of the numbers, suppose say A, is given as 280, we have to find the other number. Now from 1 and 2, if I substitute 14H here, so 14H plus H will be equal to 600. So basically H will be equal to what? 15. That is H is equal to 40. This implies H is equal to 40. So if H is equal to 40, then L is equal to 14 into H, that is 14 into 40, that is equal to 560. Done. Now I told you we have found out HCF and LCM. We know one of the number and it's very easy to determine the other one. A into B is equal to H into L. Done. So 40 into 560 is equal to 280 into B. So this is 7, this is 8, and hence B is equal to 80. That will be the answer. So find the other number. The other number is 80. Done. Now next question says, say find the greatest number that will divide 43, 91 and 183 so as to leave same remainder in each case. Now how would we proceed with this question? So here, what's the question? Find the greatest number that will divide 43, 91 and 183 and leave the same remainder. So let's say remainder is R. Now, so what is going to happen? Greatest number and say remainder is R when divided by X, when divided by some random X, So basically, according to the question, 43 is Q1 into X plus R, some quotient Q1, and again for 91 it will be some Q2 into X plus R. Again for 183 it will be Q3 X plus R, where Qi's are quotient. Okay. Now one thing, if Qi is a quotient, then what we can do, we can eliminate R. How do we eliminate R? So we say 91, so this as equation first, this is equation 2, this is equation 3. So what we are gonna do, 2 minus 1, and second time 3 minus 2, and third time we can do 3 minus 1. So basically from 2 minus 1 we get 91 minus 43. So what is the value? That is 48. R gets cancelled. So this becomes Q2 minus Q1 into X. Now 3 minus 2. So basically 183 minus 91. So this will be 92. 92 will be equal to Q3 minus Q2 into X. Now again 183 minus 43. So this is 140 is equal to Q3 minus Q1 into X. Okay, done. Now we can see that X is common to all. So if X is common to all, it means X is common factor. X is common factor of 48, 92 and 140. Actually, because X exists in all the three. X is here also, X is here also, and X is here also. Now they are saying find the greatest number. So X need to be greatest. Now X is also a common factor. So X, if it is greatest, then we can find HCF of 48, 92, 140, and that will become X. So basically 48 can be written as 16 into 3, that is 2 to the power 4 into 3. 92 can be written as 41 into 92, 23 into 4, so 2 square into 23. And 140 can be written as 2 into 2 square, that is 5 and 7. So what is common here? Only 2 is common, and 2 square is the minimum value. So this will be equal to 2 square, and that is equal to 4. So what is the answer? The answer is 4. How? We can check. When 43 divides 4, remainder is 3. And when 91 divides 4, again remainder is 3. And again when 183 is divided by 4, remainder is 3. So therefore this is true. Done. Now we are done with two of the questions. Actually there are some important properties that we need to take care of, and one of these properties, actually we already discussed a lot of property earlier, and I said ki if there are certain properties required, we will discuss it later. So let's see 6 number. So if we see 6, it's one of the very important property known as Bezo's identity. So it is written as Bezo's identity. Now why it is pronounced like this? Actually it's a French term. It's a French name of some mathematician. So that's why we say it as Bezo's. Matlab it is written like this. Bezo's identity. So what is that? Actually some of you might have read, if you have read some advanced concept from RD Sum of class 10, it's actually stated without naming the identity. So what is that? If two integers a and b not equal to 0, then there exists integers x and y such that ax plus by is equal to HCF of a comma b. Now this x and y are known as Bezo's coefficients. Okay, so what does this mean? It means if there are two integers, you find its HCF, and you can say that there can be a linear combination of this a and b such that ax plus by will always be equal to HCF of a comma b. Now can we prove it? Simple proof can be taken with intuitions. For example, suppose if there are two numbers, a is equal to 10, b is equal to 12. I am just saying a is equal to 10, b is equal to 12. Can we write some combination? You say, sir, 10 into 2 maybe plus 12 into minus 1. And what is that, sir? So 20 minus 12, that is 8. You will say, instead of writing like this 10, put minus 1 here plus 12 into 1. Now what is that? 2. 10 into 1 plus 12 into 0. I am saying none. I have said a comma b I have already said a comma b is not 0, but x and y can be 0. So 10 into 1 plus 12 into 0, so that is 10. Can we say what minimum value can we achieve using 10 and 12 as integral coefficient? We are saying HCF of 10 and 12. So HCF of 10 12 is 2. So this is the minimum value that can be achieved. This. But how? How? So let's say suppose ax plus by is equal to some k, say some smallest positive number d exists, okay, for some integer x naught comma y naught, integer x naught comma y naught. So what does this mean? It means ax naught plus by naught is equal to d. Okay, d is any random integer. We are going to prove that if d is the smallest, it will be HCF. Okay, now we can say that d divides both a and b? If we can, let's try. If what do we need to show? We need to show that d must divide both a and b, and our job is finished. Divide both a and b. But how? Let's say suppose a divides d. Okay, d is dividing a. It means d is smaller, so d divides a. Let's say d divides a. Then what we can say? A will be what? D into q plus r. Now where the remainder can vary from 0 to since we are dividing from d to less than d. Now express, we don't know whether r, what is the value of r. Don't say that sir r is equal to 0. Why? Because we need to show this that d must divide both a and b. So a is equal to dq plus r. So what will r become? It will become a minus dq. Now so this says q, and what is the value of d? D is somewhere ax naught plus by naught from here. Now so overall it becomes a 1 minus q x naught plus b into minus q y naught. Okay, now what does this show? R is linear combination, which implies R is linear combination of a and b. R is linear combination of a and b. But what we said initially, that d was, but we said d was the smallest possible combination. D was the smallest possible combination. Smallest possible positive combination. So what happened here? How can we exemplify that this r is less than d? Of course, it's written here r is less than d. So r is less than d. Now it means our assumption is wrong. But how could our assumption be better? It means r is not positive, but r equal to 0. But r equal to 0. If r becomes 0, if r is equal to 0, then what will happen with a? So a will be d into q. A will become d into q. Done. It means d divides a. Therefore, it means d divides a. D divides a. Now we can also argue by same procedure, we can say d divides b. Okay, so it means d is common. D is common divisor. Now but there is a problem. I said the minimum possible expression will be HCF of a and b. Now D is a common divisor, but how could we say that D is the highest common divisor? D can be smaller than HCF. Now to show D is HCF, say any common divisor of A and B common divisor must also divide combination of AX plus BY, must also divide combination of must also divide combination of AX plus BY. Why? This we have already proved here that D was the smallest possible combination, and we already showed that whenever there is a common divisor of A and B, we can put it in a linear combination of AX plus BY. Also D is equal to what? AX naught plus BY naught. That we have already seen here, that AX naught plus BY naught is equal to D. It means D also divides both A and B, and we have already proved. So what does this mean? It means C must divide D. C divides D. From these two conclusions, it means C is less than equal to D. What does this imply? C is less than equal to D. It means eventually D is greater than or equal to any other common divisor. So it means D is HCF divisor. So therefore D is what? D is HCF. Done. Now we can prove this. How? With an example. Okay. Let's see that whether this identity holds true or not. What we have seen? We have seen Bezo's identity, that there are two integers a comma b, then there exists some integer x and y such that ax plus by is always equal to HCF of a comma b. It means let's check it out whether it is possible or not. For example, say a is equal to 48 and b is equal to 18. Now what is the HCF of 48 and 18? So it will be obviously 6. Now by Bezo's identity, what does it say? It says xy belonging to z such that 48x plus 18y must be equal to 6. That we can find some x and y. Some x and y can be found out such that 48x plus 18y is equal to 6. So if we say 18 to 36, if I choose x equal to -1 and y is equal to 3, so this could be found out. So 18 into 3, 54, 54 minus 48, and that is equal to 6. If you ask me ki what is the correct procedure, so I can say, see here, 18 and 48, we can use long division method of finding HCF. 18 to 36 and there is 12. Again 12, what do we need to write? 18, so 12 1 12, again 6 remains 12, 6 into 2, that is 12, and this gets 0. Now what is the way? Go backwards. How? That 12 is equal to 6 into 2 plus 0. So therefore 6 is what? HCF. Again 18 can be written in terms of 12 into 1 plus 6. Again this 12, again 12 into 1 plus 6. Now 48 can be written as 18 into 2 and plus 12. 18 into 2 plus 12. So basically if we go proceed forward from 48 to 12 and write all the steps mentioned from last, this is first, this is second, this is third. Now 48 is equal to what? 18 into 2 plus 12. So can we replace this 12 somehow? Why? What do we need? We need 48 and 18 at last. We need 48 and 18 only. We don't need 12. So how can 12 be replaced? So 12 can be replaced by 18 minus 6. So 48 is equal to 18 into 2 plus 12 can be written as 18 into 1 minus 6. So basically, if I take 48 one side, so 18 into 2 plus 18 into 1, actually this will be 18 into 3, and there it becomes 48 into 1 and 6 is taken to the left hand side. So we get the answer 6 is equal to 18 into 3 plus 48 into minus 1, and hence we get our answer as y is equal to 3 and x equal to minus 1. So this is the way we backtrack. This is known as backtracking method. Backtracking method. Okay. First, check out what we need. We need only 48 and 18. So what you are required to do, you are required to replace everything from the last equation. So from the last equation it's 12. We don't need 12. So 12 is replaced from the previous equation. Again, we don't need to take this one where the remainder is 0. So if there are multiple steps, we can do it stepwise so that we eventually reach the answer. Okay, done. Now next property. What is the which property is that? Property 6, I guess. No, 7th. So property number 7 for HCF. Property 7. So it is distributive property. Distributive property. So what is distributive property here? Now, like we know the distributive property for multiplication. That multiplication distributes over addition. Multiplication distributes over addition. Over addition. Okay. So likewise, what we can say, for example, HCF distributes over LCM. HCF distributes over LCM. How? Let's check out. HCF of A comma LCM of B comma C. That can also be said as LCM of HCF comma A comma B and HCF of A comma C. That is the distributive property. Now, if you ask me how, so we can give a simple proof for that. What we will do, we'll take one prime p. Choose any one prime p in number a, b, c. I'm saying, let's say a, b, c number has some prime number in common and their exponents and exponents, let's say x, y, z, x, y and z respectively. Now what is the procedure? Check out left hand side. So we check LHS. If we check LHS, what is written here? HCF A comma LCM of B C. Now we also consider one thing here. Exponent, let's say x is less than equal to y is less than equal to z. So LCM of B comma C will be what? Here maximum of y comma z. So maximum will be z. So HCF of A. Now in A, what will be there? So we are talking of exponent. So in A, what is the exponent of P? We'll just only see P. There can be other P's also, Q, R, whatever you choose. But I am just taking any one prime and the exponents is X, and here LCM of B and C is Z. Now what is HCF of XZ? That will be X itself. Now choose for RHS. RHS is LCM of HCF of A comma B and A comma C, it will be X and X. So therefore this is also X. True. Done. LHS is equal to RHS. LHS is equal to RHS. Done. So this is the property. Now or now you will tell me ki sir, you did something here, consideration that X is less than equal to Y is less than equal to Z. So there can be other case also. Like what other cases can be there? For example, X is greater than equal to Y but less than equal to Z. Now you start doing it, again you will get, it means I'm saying ki there can be other cases also, but you start doing the same way, again you will get the same value itself. Okay, done. Now let's see example. Say one of the example, A is equal to 10, say B is equal to 15 and C is equal to 25. So here uh, in only this one I can add also another thing. Same way LCM distributes over HCF2. It means LCM of A HCF of B comma C can be said as HCF of LCM A comma B LCM A comma C. This is also true. So likewise, now we will give examples for both. A is equal to 10, B is equal to 15, C is equal to 25. So for the first part, what was there? We are required to find HCF. We are required to find, for the first part, HCF A was there, LCM of B comma C was there, and that we said is equal to LCM HCF of A comma B and HCF of A comma C. That is what we said. Now so let's see LCM HCF of 10, LCM of B comma C, 15 and 25. What is the LCM of 15 and 25? It's 75. It's 75. So what is the HCF of 10 and 75? It will be 5 itself. And what about the LCM? Into LCM HCF of A comma B. HCF of A comma B is 5. Again HCF of A comma C is again 5. So answer is 5 itself. So these two are true. Now LCM. Let's check out LCM. A, that is 10. HCF of B comma C 5. So what is the LCM of 10 comma 5? That is 10. Now HCF of LCM A comma B, 10 and 15. What is the LCM? 30. A comma C, that is 50. So what is the HCF of 30 and 50? That is 10. Highest common factor that divides this 2 is 10. So proved. These two are equal. Done. That is what we wanted to prove, and this has been done. Now another very important property of HCF and LCM, 8, very important, VVI. From Olympiad perspective, this part is very important. Now it is known as shifting property of HCF. Shifting property of HCF. Now what is this shifting property of HCF? It says for any integers A and B, HCF of A comma B is same as HCF of A plus B and B, or A minus B and B. Now this is very important. It means if we write it mathematically, so HCF A comma B is equal to HCF of A plus KB comma B for K belonging to any set of integers. That is the meaning. Now how do we prove this? Proof. So it means HCF of A comma B is there. So if you add both of it and find the HCF with respect to some other number, it will be same. We will do with an example, but say how do we prove this? Now first we can choose some of the HCF. Let it be, let D be common divisor. Suppose let D be a common divisor of A and B. A and B. Then what is going to happen? A will be equal to D into X. B will be equal to sum D into Y for X, Y belonging to set of integers. X, Y belongs to a set of integers. Now, what we need to check? We need to check if D divides A plus KB. So let us check. Now, A plus K into B will be equal to D into X plus K, let it be. B can be written as D into Y. So basically this becomes D into X plus KY. Now this X plus KY is an integer. Why? Because X is integer, K is integer, Y is integer. So X plus KY is an integer. Now, so D divides A plus KB. So this implies D divides A plus KB. Done. Now if D is the common divisor of A and B, it means it is also the common divisor of A plus KB and B. So it means complete set of common divisors of for both pairs Why? Because I chose any of the common divisor. I didn't explain that D was HCF. I'm just saying D was any common divisor. So it means if D divides A plus KB, this is true. D always divides. It means complete set of common divisors for both pairs A comma B and A plus KB comma B are identical. Why? Because every common divisors you choose, it will divide both. It means if all D are same, then HCF is also same. Then HCF, that is highest common divisor, you can say highest common divisor is also same. Done. Now this is very amazing property and very important property. It means this actually this forms the foundation of Euclidean algorithm. What we did in long step method actually was what? We wanted HCF of A comma B. So what were we doing? We were finding reminders and then we were using the property. How? If A is equal to QB plus R was there, then R was A minus QB. Therefore, what we were doing, HCF of A comma B, we were writing HCF of A minus QB comma B. Okay, and that is equal to HCF of remainder comma B. That is what we were finding out. Superb. Remember that we used to see the remainder and then we used to take the other number and then divide. So this, I am talking of this long division. Euclidean algorithm, I am talking of this long division. What we were doing, we were taking the remainder, we were dividing by the other number B, and then at last 6 and 12 HCF came out to be 6, and then it is also the HCF of 18 and 48. Why? Because of the same reason here. This is the reason. This Euclidean algorithm is the reason, and this property is of vital importance. Okay, if we need to take example, let's say A is equal to, again I will choose the same, A is 48, B is 18. Now what is HCF? We know HCF is equal to 6. So now we can check one thing. HCF of 48 plus 18 comma 18. Now 48 plus 18 is what? It's 66. HCF of 66 comma 18. So what is the HCF? 66. 6 is the only common factor. So this will be equal to 6 itself. So this is true. Now even if we check HCF of 48 minus say 2 into 18 comma 18, again it will be same. Let's check out HCF of 12 comma 18. and that is again 6. So the property always holds true. Done. Very important property. Now next, ninth, property number 9. So what we are talking of in property number 9? We are talking of HCF with co-prime numbers. HCF with co-prime numbers. Now in this case we can say HCF, if HCF A comma B is 1, it means when HCF of A comma B is 1, it means A and B are co-prime. A and B are co-prime. So what we can say here, then HCF of A comma BC is equal to HCF of A comma C. True or not? Why? Because B is not divisible by A. So finding HCF of A comma BC is always finding same as HCF of A comma C. Proof के लिए what is required? A comma B has no common prime factors. So it means if there has to be an HCF of A comma BC, it means all the necessary common factors must come from A and C only, since A and B has no common factors in common. Okay, so done. Let's see the example. If A is equal to 7, say B is equal to 4, and C take it as something 7, 4, let's say 14. Now what is HCF of 7 comma 4? So this is 1. Now what is HCF of 7 comma 4 into 14? Now this will be same as HCF of 7, since 7 is 7 and 4, HCF is 1, so it will be same as HCF of 7 and 14, which is equal to what? Which is equal to 7. Even if you multiply 7 comma 56, the HCF is 7. So actually it is true. Actually it is true. Next. Now again very important property for Olympiad. Very important property. This is VVI. Now rest of all the properties are VVI. This is VVI. Again the above one, very important. You don't need to miss this. Thanks. This is VVI. Now again next one, if I say there is something known as scaling property. What do we mean by scaling property of HCF and LCM? So for the scaling property, let's see, if K belongs to Z plus, then HCF of KA comma KB will be equal to K into HCF of A comma B. Now this seems true. Again for LCM of KA comma KB, this will be equal to K into LCM of A comma B. This is true. Now why? So it's simple. क्या है? Suppose HCF of A comma B is equal to D. Let HCF of A comma B is equal to D. It means D is the greatest number that divides A and B. So we can write, which implies A is equal to dx and B is equal to dy. And apart from this, what we can say, HCF of x comma y, HCF of x comma y is equal to 1. They are co-prime. They are co-prime. Now this is the condition. So if they are co-prime, so let's look at the number Ka and Kb. So Ka can be written as K into dx. That is Kd into x. Again Kb can be written as K into dy, which can again be written as Kd into y. Now we can see from this two, we can see Kd is common divisor. Kd is common divisor for both K and Kb. Common divisor of K and Kb. Done. Now is this GCD of both? Is this GCD of both? that KD is GCD? Is GCD equal to KD? I guess this is true. Why? Think of one way. X and Y are co-prime. It means X and Y have no common factor. So what is the greatest common factor that we can see? So this is KD, and therefore that GCD of K and KB is equal to K into D itself. Done. So we can do one thing. We can write HCF KA. Therefore HCF KA into KB can be written as K times HCF of A comma B, and same goes for LCM. Same for LCM. Done. Same for LCM. We can take an example. Say A is equal to 10, B is equal to 15, K is equal to 3. Now we can say what is HCF of 10 and 15? It is equal to 5. Now also HCF of 10 into 3, that is 30, and 15 3 45 is equal to what? 15, which is equal to what? 3 times HCF of 10 comma 15, and this is true. This property holds true. Then now since it has already been 1 hour 16 minutes approximately, so we will be doing some part of this HCF and LCM and the Olympiad questions in the second part of the video series. Thank you.